Hi, I'm Agasthya Metpally, a rising junior from Raleigh Charter High School, North Carolina. Our study asks a simple but clinically important question. When we use computational tools to predict whether a gene variant is disease-causing or not, do those tools work equally well for loss-of-function variants and gain-of-function variants? We tested alpha missense against Revel in monogenic diabetes genes, and the difference matters for clinical variant classification. Here's why direction matters. Most predictors are trained mostly on loss-of-function data, but gain-of-function variants work differently. They overactivate the protein, so they may not show the usual conservation or structural signals. Three genes, ATP binding Cas8, KCNJ11, and glucokinase are a clean test case because these genes show variations in both directions and have well-characterized functional consequences from electrophysiology and enzyme kinetics. So we can ask, does accuracy depend on which way the variant acts? We start with 131 pathogenic variants from Hopkin et al.'s paper, split evenly into loss and gain-of-function variants, then tested on additional four validation sets: the DeFranco clinical cohort, a glucokinase deep mutational scan of 6,000 variants, a ClinVar expert panel cohort, and a curated gain-of-function variants from the GO-F-Cards database. The key move is calibration. Instead of default cutoffs, we set tool-specific thresholds against ClinVar, so both tools sit on one common evidence scale, making the comparison accurate. Here are our results. At the strong threshold, alpha missense caused 61% of loss-of-function variants, but only 29% of gain-of-function, a 31-point gap. Rebel leaned in the same way, but its gap was smaller, only 19 points. Here, panel E exhibits this clearly. Both tools do better on loss of function at every tier, and the more accurate tool overall, AlphaMissense, actually has a bigger blind spot. Could this just be an artifact of how variants were labeled? We tested that with label-free dataset, a deep mutational scan of glucokinase, 6,000 variants with enzyme function measured directly. The gap holds. AlphaMissense undercalls the gain-of-function variants by 36 points, with no clinical labels involved at all. So this is the predictor's behavior, not a quirk of the data. We pooled everything, 7 strata across 5 databases, in random effect meta-analysis. For AlphaMissense, the gap is 30.9 points. For Revel, however, it's only 20.2. And the direction is the same in every gene and every dataset, with low heterogeneity. So it's a significant systematic effect, not just an odd cohort. Now the finding that surprised us the most. In independently curated gain-of-function variants from the GO-F-Cards database, the ranking flips. Revel caught 69%, while AlphaMissense only 38%. For the variants where a miss is most dangerous, the less accurate tool is actually safer one. Two of these, KCNJ11, causes Den syndrome, the most severe form of diabetes, and both slip under AlphaMissense's threshold. What does that mean for classification? We recalibrated against the ClinVar panel using likelihood ratios. At alpha missense's strong cutoff, the likelihood ratio is only 6.1 for loss of function and 4.9 for gain of function, well short of the 18.7 you need for strong evidence. So an alpha missense strong call really only earns moderate support. The default weighting gives it way too much credit. So, 4 practical implications for ACMG classification. Downgrade alpha missense from strong to moderate for these genes. Ask for functional evidence before calling a gain-of-function variant pathogenic based on only computational predictions. Use Revel as a first pass filter for gain-of-function since it misses fewer. And calibrate thresholds per gene, which streets straight into the ACMG version 4 framework. In conclusion, AlphaMissense systematically underdetects gain-of-function variants in these 3 genes, and it holds across clinical cohorts, a functional scan, and curated databases. The safe move is to treat AlphaMissense's strong as moderate here, add functional support, and lean on Revel when a gain-of-function call cannot be missed. Thank you for your attention.